Hello and welcome to Diplomatic Derivatives. In this series of lectures, we have started talking about vector algebra, where we have already uploaded 3 videos that talk about vector definition, position vectors, as well as vector addition and subtraction, which is very important. So make sure you check those out. The link will be in the description box below. Before moving on, make sure you understand those concepts. Now, today we are going to talk about another concept which is also very important, unit vectors. So the main thing is that first, once your base is clear about all these topics, we will be able to perform theorems, we will be able to perform exercises. So make sure these concepts are crystal clear to you. Now moving on. What is a unit vector? A unit vector is a vector of length, that is magnitude 1, that points in a specific direction. Now what is that specific direction? That direction is direction of a vector. Alright, whatever vector we have, it will point in some direction, right? And unit vector tells us that direction. Its magnitude is 1. Why is its magnitude 1? Because magnitude does not matter. It just tells us the direction. And for something to tell direction, it must exist, right? So for its existence, we will just give it a value which is 1, nothing more than 1, right? So that's why we have a unit vector which is having a magnitude 1 and points in the direction of a vector, of any given vector. So magnitude of a unit vector is going to be 1. So either that direction will be x direction, direction of y, or direction of z. Alright. Notation usually written with a hat like I, j, or k. So if we have a unit vector I, it tells us that the vector will be having some direction in the x axis. If it's j, it's some direction along the y-axis. K, some direction along the z-axis. That comes in 3D. Okay, I, j in the 2D and k in the 3D. So unit vector is just having a magnitude 1 and tells the direction of a vector. Okay, it comes in combination. So I will, because we have already seen in vector notation that, for example, we have any vector which is axi plus ayj. So I is for the x and j is for y, right? So it tells us how to draw that vector in the x and y coordinate according to the x direction and the y direction, and then somewhere within the x and y direction that vector will be placed. So ijk helps for that purpose. All right. Now, why are these unit vectors useful? Number one, direction only. They describe direction without regards to magnitude. Magnitude does not matter. What matters is the direction, and that is what we get from the unit vectors. So let's suppose we have point A. So A is 2, 3. 2 is in the x and 3 is in the y. So it's 2i plus 3j. Here unit vectors are helping us out to make the vector in the either in the x direction, in which direction, how many points in the x direction and how many points in the y direction. All right. We have already done all of these things. It's just to make sure that we do not miss anything. Building blocks, any vector can be expressed as a combination of unit vectors. So it's, for example, point C is I plus 7j. This is I minus 4j. This is 0, 0. This is 3 minus j. 3i minus j. So these unit vectors basically build up main vectors. Okay. Simplification, they make vector operations like dot product and cross product easier. This also is very important that we will be tackling in another video in the future about the vector dot product and cross product. So unit vectors help in that as well. Now, common unit vectors, again in the 3D Cartesian coordinate system, I, which is unit vector in the x direction. Now how do you represent that? 1, 0, 0. What does this mean? Whenever we write a vector, how do we write? We write, let's suppose let's suppose we have vector A and the point is A 2, 3, right? So this is 2 in the x direction, 2 units in the x and 3 units in the y, right? Similarly, this is 1 unit in the x, 0 units in the y, and 0 units in the z direction. Okay, and why is that so? Because I tells the direction in the x axis. Okay, so and we know the magnitude is 1, so it is only for the x point. So only for the x direction we have a magnitude. For y and z we do not have any magnitude. Okay, so in the x direction it is 1, and in the y and the z direction it is 0. Okay, this is a representation, this is vector notation for unit vector I. Like this is a vector notation for point A, this is a vector notation for I. Okay, similarly for j, it's in the y direction, so x and z are going to be 0, only we will have magnitude in the y axis, that is 1. Similarly for z, it will be 0 0 1, that is unit vector k. All right, simple. Now we will have a formula how to find a unit vector. Also a question can come, find a unit vector using means you will be given some values and you have to find a unit vector for that. How do you do that? You have any vector given to you, that is vector v. Let's suppose x, y, z are the points. Okay, so x, this is in the I unit vector for I, this is for j, and this is for k, magnitudes, right? Now how do you find the unit vector? First of all, what do? You will be given any vector. For that vector, you will first find the magnitude. Okay, we have already done this in one of the videos, so make sure you, in the first video in this series of vector algebra, also given in the description box below. Finding the magnitude, the formula is magnitude of v is equal to square root x square plus y square plus z square, right? Next step is divide each component of the vector by the magnitude. So unit vector is equal to vector v divided by magnitude of v. This is the formula for unit vector. The only thing you have to remember, vector v, unit vector v is equal to vector v divided by magnitude of v. Okay, so what is a vector v? It is this normalizes the vector, converting it into a unit vector. So what do we get here? We're converting the vector into a unit vector. Okay, this is the formula to find a unit vector of any given vector. Okay, so what you are doing is you just write the vector. This is xi plus yj plus zk, right? So this will be unit vector v is equal to xi plus yj plus zk divided by the magnitude of v. Okay, we will see an example here. We have a point given which is v equal to 3 4, right? Magnitude you have to find first. Magnitude of v is equal to root of 3 square plus 4 square, which is equal to 5. That's it. What is a unit vector? Unit vector is equal to vector v divided by magnitude of v. Vector is 3i plus 4j from here divided by magnitude, which is 5. So you have 3i plus 4j divided by 5. This is the unit vector. All right. Simple. There is no other rocket science in this. Simply unit vector is vector divided by magnitude of the vector. Now is again just to make it much more simpler, geometrical interpretation. Our unit vector is like an arrow of length 1, so it's going to be any arrow. Okay, what is unit vector as in a graphical notation? This is how we see it in a graphical notation, that it's any arrow in the length 1, okay, not more than 1, pointing in the same direction as the original vector. So if you imagine placing the tail of this vector at the origin, it always has the tail on the origin. The tip lies on the unit circle in 2D or unit sphere in 3D. So if we imagine a circle in the x and y axis, this is a circle. Its radius is 1, okay, not more than 1. So 1 in all the coordinates. Okay, so you make a circle. This unit vector will be either here, or this unit vector could be, let's suppose, here. Okay, it could be, let's suppose, here. It won't go beyond this circle. Okay, it will always stay inside this circle. Okay, so its tail will be at the origin and it lies within this circle because its magnitude is 1. All right, it is just used for the purpose of telling the direction. All right, that's all for unit vector. So it's very simple. The concept is very simple. Just you need to understand the formula. What is the formula? We will just write it here. The formula is unit vector, any vector. So let's suppose vector v. Okay, we're just taking v because we just talked about it. Unit vector v is equal to vector v divided by the magnitude of v. This is the formula for unit vector. I hope it was clear. In the next video, we'll be moving on to another topic which is again in part of vector algebra, which is the linear combination of vectors. So make sure you like, share and subscribe to my channel. I'll be continuing with the vector algebra portion in the future videos, so stay tuned, and that's all for today. Bye bye.